Alright, so today's topic is going to be that of implicit differentiation. Alright, so let's just talk about two types of equations here real quick. Whenever you have a equation that is written in the form of y equals something or f of x equals something, that is going to be called an explicit equation. For example, if you have y equals x squared plus 2x minus 5, that is an explicit equation because it is written in as y equals. This equation is already solved for y. If it was f of x equals this, it'd be the same thing. It is an explicit equation. We now have specific rules and techniques for being able to find the derivatives for a lot of different types of explicit equations. We know how to find the derivatives for polynomials. We know how to find the derivatives for our trig or natural log or exponential functions. So lots of different types of functions we know how to find the derivative of when it is an explicit equation, when it's y equals. All right, so what we are going to now look at is going to be when you have an implicit equation. An implicit equation is an equation that has not been solved for y. An example of this is the equation of a circle with a radius of 4. If you remember, a generic equation for a circle is x minus h squared plus y minus k squared equals r squared, where hk represents the center of your circle and r is your radius of the circle. So if you have a circle centered at the origin, that means h and k would be 0. So that would leave you with x squared plus y squared. And a radius of 4 would be 4 squared, which is 16. All right, so that equation we have right here is x squared plus y squared equals 16. This is an example of an implicit equation because our equation has not been solved for y. Now, it is possible to write this particular equation explicitly by solving for y. And so what you would do is you would subtract x squared over to the other side, and then you would have to take the square root of both sides. So what you end up with then would be y equals plus or minus the square root of 16 minus x squared. Now graphically, plus the square root of this, that would give you the top half of your circle, and the negative square root would give you the bottom half of your circle. We have to write them separately because together they would not be a function, and so independently they are separately functions. We can now treat this as two functions where one is positive, one is negative, and we could find the derivative of this as well. So we know how to find the derivative of our explicit equation. And so let's take a look at this on this slide here. I've already pre-done this. I just took the positive square root and the negative square root, wrote them separately using rational exponents. And then taking the derivative, you bring your 1/2 to the front and subtract 1/2. Subtract 1 from that, which gives you negative 1/2. But then don't forget to multiply by the derivative of the inside part here, which is negative 2x. That is our chain rule part of this. So we've got chain rule right here. And we did the same thing over here, so this also is chain rule involved. And just simplifying this a little bit, this 2 and this 2 will cancel out with each other. Same thing over here, those would cancel. You're going to have a negative from right here, so we keep that negative. and the x will be up here in the numerator. This parentheses to the negative power, so that goes to your denominator. This would be the derivative of our function, which is really just the derivative of the top half of our circle. Over here you have a negative and another negative that are being multiplied together, which ends up being a positive x over the square root. And this would be the derivative of everything on the bottom half of our circle. Now, the problem with an implicit equation is that many of the equations cannot be solved for y. Because of this, we need a different way of being able to find our derivative. Hence the need for the method called implicit differentiation. This really is just making use of the chain rule to find the derivative of each term with respect to x, and then solving for dy dx. Now, let me take a second to explain something real quick. Let's say that we have the equation y equals 2x cubed. Now, when we take an equation, it is balanced, and it will stay balanced as long as you do the same thing to both sides of your equation. So what we are going to do is take the derivative of both sides of our equation. Now, we need to think of this in terms of chain rule. We are differentiating with respect to x. So when we take the derivative of y, the derivative of y is 1. But then what we are doing is multiplying by the derivative of the inside part here. And the derivative of this is dy dx. Or in other words, it is the derivative of y with respect to x. So what we did is we took the derivative of y, which is 1, and then multiplied by the derivative of the inside part, which is dy dx. All right. So then over here, when you take the derivative of this, you are going to get 6x squared, but you've got to think of this as an inside part. And so when you multiply by the chain rule, you're going to be multiplying by the derivative of x with respect to x. Now, dx dx is really just 1, but that's technically what we are doing. And so what this gives us then is dy dx is equal to 6x squared. That's how we typically will see our derivative. All right, so let's take a look at this equation right here, which is what we had originally on that slide. This is just simply a circle with a radius of 4 centered at the origin. And we want to find the derivative of this equation. Remember, we said that we can take the derivative of both sides of our equation, and this thing will stay balanced. So we need to think of this as an inside part and an inside part here as well. So when you take the derivative of this, use your power rule. So you're going to get 2x raised to the first power times, and then you're going to be multiplying by the derivative of the inside part, which means we are multiplying by the derivative of x with respect to x. All right, so that was the derivative of our first term. Now we're going to do the derivative of the second term. So on the second term, you're bringing the 2 to the front, subtracting 1. So that will make this plus 2y to the first power times, and then the derivative of the inside part, which is our chain rule. So that means we are multiplying by the derivative of y with respect to x. Equals, and then the derivative of 16 is 0. All right, so cleaning this up just a little bit, this first term is just going to end up being 2x because dx is 1. Over here you're going to have plus 2y dy dx is equal to 0. Now always keep sight of our goal. We want to know the derivative of this equation, which means we want to know what does dy dx equal. Well, dy dx is right here in our equation. So what we're going to do is solve for dy dx. To do that, you're going to subtract 2y to the other side. So that gives us 2y dy dx equals negative 2x. And then dividing by 2y. The 2's will cancel. End up with negative x over y is what dy dx is equal to. So you can also find the second derivative using this same method. This will involve using the quotient rule for this particular equation. What we're going to do is just take the answer we just came up with, which was dy dx equals negative x over y, and we're going to find the second derivative of this. And so on your second derivative, you're going to have the negative still out front. This is going to be using quotient rule, which is going to start with the bottom times the derivative of the top, which would be dx minus the top times the derivative of the bottom. Well, the derivative of the bottom is the derivative of y with respect to x. And all of this will be over y squared. Now, what we want is to clean this up a little bit. We don't ever want to keep dx's or dy dx's in our problem, because what we want is a derivative in terms of x and y, not a derivative in terms of dy dx. We want a derivative in terms of x's and y's. So the dx is just 1, so you're going to get 1 times y, which is y, minus x times, now dy dx we know from up here is equal to negative x over y. So what you're going to do is take this value and plug it in to dy dx. And so we end up with a negative x over y right here, and that's over y squared, which, simplifying this just a little bit, you're going to have a negative times a negative, which will give you a plus right here, and then x times this x will give us x squared over y. All of this is over y squared. And so that is going to be equal to the second derivative of y with respect to x. All right, so let's take another example here. On this one, it says, what is the derivative of this equation? And then we're going to carry it a little further and find out what is the equation of the tangent line at x equals 2. All right, so the derivative of the equation, we just start going through the equation term by term, finding the derivatives. All right, so start with your first term right here. So the derivative of that would be 2x times dx, which I will just go ahead and start leaving the dx part off because that's just always equal to 1. Just remember that it is technically there though. All right, so then you're going to have minus, now here you have x times y, which means we need to do product rule. All right, so our product rule is going to be first times derivative of the second, which will be dy dx, plus the second, which is y, times the derivative of the first. And the derivative of the first would be dx dx. So I'm going to leave that off because that is just 1. Now we have plus, and then the derivative of this term is 2y, but then remember the chain rule because it's like having this y in parentheses here. So this would be times dy dx equals, and then the derivative of this is 0. All right, so we're going to clean this up a little bit and then solve for dy dx. Distributing the negative, you're going to get minus x dy dx minus y plus 2y dy dx equals 0. Now, our goal is to find out what does dy dx equal. So we're solving for dy dx. Think of this as a variable. That's what we're solving for, which means every term that does not have a dy dx on it is going to go to the other side of our equation. All right, so we're going to end up now with negative x dy dx plus 2y dy dx equals y minus 2x. All right, so we added this y over to the other side, and then we subtracted this 2x over to this side. Now we need to isolate dy dx, and both of these terms have dy dx in them. So you're going to factor out dy dx, which will leave you with negative x plus 2y equals y minus 2x, and then solving for dy dx, we get dy dx is equal to y minus 2x over 2y minus x, or negative x plus 2y. It doesn't really make any difference. All right, so this is our derivative. Okay, that is the first thing that we needed to find. Now the question here is, what is the equation of the line tangent to this graph at x equals 2? Well, at x equals 2, we need to find out what the y value is. All right, so at x equals 2, you're going to get 2 squared, which is 4, minus 2y, plus y squared equals 19. That was just taking our 2 and substituting it in for the x to find out what our y value is. This is quadratic, which means we need to set this equation equal to 0. So we're going to subtract 19 over here, making it minus 15. Then we factor this, which goes down to y minus 5 times y plus 3, giving us y values of 5 and negative 3. So there are two places where you're going to have a tangent line at x equals 2. And so to find out the derivative at each one of those places, we're going to find dy dx evaluated at 2, 5, and then we're also going to find dy dx evaluated at 2, -3. So that's what this vertical bar means. Just means that we're evaluating this thing at these values. Okay, so all we're doing then is just taking this 2 as an x value, this 5 as a y value, and plugging them into our derivative right here. All right, so you're going to get 5 minus 2 times 2, which is 5 minus 4, or 1. And then you're going to have 2 times 5, which is 10, and 10 minus the 2 is 8. All right, so then the other derivative, we're putting -3 in for the y, 2 in for the x, so you're going to get -3 minus 2 times -3. I'm sorry, 2 times 2. So -3 minus 4, which is -7. And then here you'll have 2 times -3 is -6. And -6 minus 2 is -8. -7 over -8 reduces to a positive 7/8. So therefore we have two tangent lines. One is going to use this as a derivative, the other uses this as a derivative. So the tangent line for this one is going to be y minus 5 equals 1/8 times x minus 2. And the tangent line for this one is going to be y plus 3 equals 7/8 times x minus 2. All right, so our next problem says what is the derivative of this equation? So let's once again start out term by term finding the derivatives of these. So your first term is going to be 3x squared dx dx, so we leave that part off, minus 2, which is a coefficient or a constant, so we're going to bring this part outside parentheses, and we're going to do chain rule with this, and then we'll distribute the 2 after we're done. All right, so chain rule is going to be first, which is x, times derivative of the second. Well, the derivative of the second is going to be 3y squared times dy dx, because again you got chain rule in there. We're taking the derivative of the y. Now we have plus the second, which is y cubed, times derivative of the first, which would be dx dx, so we're going to leave that off, that's 1, equals, and then we have 18 and the derivative of y with respect to x. So here the derivative of 18y is just the 18, and then times the dy dx for the derivative of that part. All right, cleaning this up again, you're going to get 3x squared minus 6xy squared dy dx minus 2y cubed equals 18 dy dx. And our goal here is going to be to solve for dy dx. So we need to get terms that have dy dx on the same side of the equation and everything that does not have a dy dx on it will stay on the other side. So what I'm going to do is I'm going to move this term over to this side by adding it. So that's going to give us 3x squared minus 2y cubed equals 18 dy dx plus 6xy squared dy dx, and then we will factor out dy dx out of both terms, so we'll have dy dx times 18 plus 6xy squared. Now we can solve by dividing by that parenthesis, which will give us 3x squared minus 2y cubed over 18 plus 6xy squared. And that is our derivative with respect to x. All right, so now it's time to practice your homework assignment. And if you have any questions, please remember to ask.